Please put your hands together for the keynote session titled Off Script, Small Stories in Big Science. Can we please have a huge round of applause? Thank you. This session featuring Amitabh Sinha, Deputy Editor at the Indian Express, Professor Urbasi Sinha, who heads Quantum Information and Computing Lab at the Raman Research Institute, and Dr. Anil Bharadwaj, astrophysicist and director of Physical Research Laboratory, PRL, who will be talking about how journalists can spotlight the human stories and incremental advances in quantum science, AI, and space exploration, making these complex fields engaging and accessible to wider audiences. And sorry, I forgot to mention that this session also has Amitabh Nag from the Digital India Bhashini. Can I please request all the panelists and the moderator to head over to the stage? Thank you so much.
Welcome all of you here to this conference, and a very warm welcome to our panelists here. The theme of this conference, as you can see, is the underreported. This session we'll be discussing science that is certainly not underreported. In fact, there is a lot of excitement about these science specifically, and we have representatives, we have scientists who are working in different fields which are certainly not underreported. Artificial intelligence, quantum, and space sciences, of course, probably creates the maximum excitement in the Indian audience. Probably nothing excites people more than space in India, and not just in the last few years, but yes, certainly more so in the last few years. But, apart from the excitement, as I said, these are very broad fields. These are not underreported, but yes, there is, in that all that excitement, there is a lot of hype as well, possibly leading to some kind of misreporting, a lot of hyperbole sometimes. So this session, we'll talk about these three specific scientific fields. What are the realistic sort of possibilities related to these sciences? What are how to improve our communication in these particular fields? What are the things to avoid? And what is the genuine excitement all about? So we'll try to explore those questions with the overall objective of improving the way we communicate about these scientific fields, right? So we have very genuine experts in each one of these, and we'll talk to them about these questions. If we can begin, all of you, and we can go one by one, probably. What is it that makes your specific field so exciting? Why are people so excited about? Do they fully comprehend or understand it? I can understand a little bit about space sciences because there's some things to see, but in quantum, we don't see anything, and still there is a lot. The number of shops that I have seen which are named quantum, it's very surprising, but it does happen. So if you could begin, and I can begin with Urbasi, and then we can come around. So what is it that leads to this kind of excitement about your field, and how much of that is realistic?
So why are we excited about quantum? So this is a good question because, quantum is, do you know that we are celebrating 100 years of quantum mechanics this year? And I think every institute which has anything to do with quantum is celebrating it in some way or the other. And next year is International Year of Quantum. So quantum is not a new field. It has been around for at least 100 years. And so many things that we see around us are results of quantum innovations, whether it's the MRI machine, whether it is the laser pointer, which we are not using in this talk. But then all these things are quantum inventions. So quantum is not new. So then, of course, the question becomes even more interesting as to why are we so excited about it now? Or let's say for the last 10 years. We have not been excited before that. Not so much, I would say. That is because, you see, we actually have become much better in terms of our ability to, make these quantum states, whether it's a single particle of light, matter, whatever you have, a single particle. We are able to manipulate them with precision, and we are able to measure them as well with precision. So our abilities to deal with quantum systems has really gone up over the last few decades. That's because of advances that we have created in terms of our, I would say, experimental ability. Because a lot of the quantum that we know of, although the applications I talked about are very, very commonplace, there is a lot of theory which precedes experiments in quantum. So theory has been around for much longer. So now we have the ability to be able to realize a lot of these theories in practical implementations. And so this is something, I would say, 2 to 2.5 decades old phenomena, that we have mastered this ability. And that is what gives rise to applications now, which weren't possible, let's say, before the 90s. I mean, I would just stop at the 90s. Before that, I don't think we had anything major happen in this new era. So we say that, we had the first quantum revolution, and now we have the second quantum revolution. And the second quantum revolution is about these new applications. So what are these new applications? I think, maybe the people who report on the quantum are already familiar with this. So, but I will, definitely. So this particular part of the thing is very sedate, right? Like there is nothing off. I mean, we are just stating facts here. So these are in the computing domain, in the data security domain, and in the ability to have better quality sensors. So we have the possibility of quantum computers, or I would say at the moment we have quantum processors, which would become a certain computer at some point, and we'll come to that in some, in the next discussion we have. Then this is going to give us the ability to be able to compute certain things much faster than many other classical, counterparts. And so that certain things I will discuss in a next question that you may or may not raise. I will still discuss it. Okay, because this is the part about your hype, so I don't subscribe to the hype, and so I will make that point. But when we begin, we always begin in a polite and reserved manner, and it's the first session after all. And so that is the computing. Then we have the data security, which of course is actually a little more real, I would say, in terms of what is possible now. That is because we are actually using laws of quantum mechanics to make data secure in a very different way from what we are used to in terms of how things are secure now. And that is actually implemented in banks, in defense, and so on. So it's much more real, I would say, than the computing counterpart. And then we have the quantum sensors, which we are also using, so we are going to have little versions of MRIs, which would be based on, let's say, vacancies in diamond, which is actually also happening in the real. So these are practical applications which benefit all of us, whether we like to do things faster because it, makes certain things possible, which otherwise wasn't, whether we want money in the bank to remain for our progeny, which I hope, as scientists, we don't have a lot to guard, right? But then whatever little we have is going to remain secure. And likewise, sensors, right? So these are all this is just a nutshell. And then we have the materials aspect, where we are able to, generate the possibility of new materials, which will make all these things better. So that's a horizontal. And these are verticals, as we call them. So these are the applications which are now much in the forefront. A lot has happened in them. I will want to touch upon exactly what has happened and what has not happened, maybe in some other, question that you may raise. And that is what gives rise to the current excitement. And the excitement is warranted because of what is possible, not because of the hype. So I will rest my case now and let space and AI speak, right?
Yeah, Professor Bharadwaj, please.
Thank you. And let me begin by, first of all, congratulating Science Journalism and Science Journalist Association of India for having this kind of association in the country and hosting this second conference. And I do believe, do clap for yourself. So this is very important as the country is growing, and more particularly if you talk about space science. It has become a buzzword with every kid talking about what's happening in space in terms of what ISRO is doing, as Professor Sunil Bhagwat was mentioning, and the Chandrayaan missions and things like that. But space science includes a very vast domain of science and technology. If you look at space, anything about the Earth is space. And then people divide it into different layers as you go up from boundary layer to stratosphere, troposphere, mesosphere, ionosphere, thermosphere, sun, planet, and then beyond. Now the question comes is, how do you explore them and how do you go about it, doing it? And what is the science journalism happening in this area? Let me quote one thing which started in the new millennium when India started talking about going to the moon. And a journalist asked then Chairman ISRO, Dr. Kasturi Rangan, can India afford to go to the moon? And his answer was, can India afford not to go to the moon? That means we had a confidence in terms of our capabilities to go to the moon in the new millennium. And that's how the whole program got steered up, that we should now start looking at technology development which will take us beyond the planet Earth also. So that means space science is driven by science and technology together. It is not just the science aspect, it is also the technology aspect of it. And once we look at the technology aspect, we see rocket going up, and you see thousands and thousands of subsystems working together in unison to have that success. But it is only the rocket which takes the satellite into space. Once the satellite is put into space, the satellite has to perform and go into correct orbit. And after that, the instruments on the satellite has to work and communicate back to the Earth. So it is a whole gamut of different engineering aspects of engineering and science coming together to have the space science and technology. And as all of you must have heard about and seen, actually 23rd of August 2023, last year when we landed onto the moon in the southern polar region, making India the first country in the world to land in the southern polar regions. Nobody has landed there. But if you look at back and talk about 2019, and we try to attempt the landing on September 7th, 2019. And we all know what happened. But those are failures, I should say, are stepping stone for success, because in space, you have to be 99.9999% accurate. Even a smallest of things, which if you not notice it, can create havoc. And therefore, one has to be 100% sure when you are taking this kind of missions, because you need to have it. You need to do it. There is no second chance in space. Space doesn't give you any chances. So you have to test and test and test in the ground to make the things sure that everything happens safe in space. I will like to point out one more thing, because AI is going to come next. And people are talking about AI and ML. But I don't know how many of you are aware about the Mars orbiter mission, which ISRO undertook in 2013. And if you look at the capability which was built into the spacecraft, it was called a smart spacecraft or a mission, because AI ML was built into that for the first time. Why? If you talk about that time travel delay of the signal going from Earth to Mars and back to Earth, it can vary from almost like 8 minutes to 45 minutes. And therefore, if you send a signal and say, how Mangalyaan or Mars orbiter mission, you are okay, and you keep waiting for the signal to come back to say, yes, I am fine. We call it mom. Mangalyaan or Mars orbiter says mom. And so we always say we have sent mom to the Mars. But it has to be built in a way that the spacecraft takes of its own the decisions and continue to work without waiting for signals from the ground. And if you look at the orbit insertion, which of course makes India the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt, it was a blind insertion. Blind means no signal communication to the Earth. It was happening from the back side of the Mars. We were all waiting in the mission control for almost 20 minutes to wait for signal to come to tell that we have got inserted. So these are the kind of technologies which is built up into the systems and subsystems to work perfectly well when we are talking about the space missions. And I believe that I'll be talking a little bit more into details in the next cycle. Thank you.
Amitabh.
Yeah. Thank you, first of all, for inviting me here. And of course, I concur with Professor Bhagwat's talk about, science being underreported or achievements of science being underreported, and compliment SJAI for organizing this seminar so that, we are in a position to recognize this fact and improve upon it. Now, coming back to why AI or technology is generating, few of the technologies generating a lot of interest is because, any technology generates interest because it has a potential to help the mankind to do things better and benefit it. So, there is a reason why people start looking at it very differently. Yeah, people start looking at it very differently. And the possibilities, as it was said that AI, these technologies have been there, at least the theories have been there for a very long time. But the reason it is generating interest is that it is now the basic, framework has progressed so much that these technologies can be deployed at mass scale. And that is what the AI part of it is, coming up to be. AI is currently proliferating because you have GPUs which can process much information much faster than what used to be done earlier. So there's a possibility of AI getting deployed in mass scale. There is the two factors which actually built up the AI. One is the data which is there in plenty today, and second is that the ability to use that data to teach the machine what it should be doing. The way we teach our the kids learn over a period of time by seeing things happening, and that is what the machine can be taught at a very short period of time because of the GPU power. This emanates a lot of possibilities. Now the issue is that how do we use these possibilities and actually deploy it, and the deployment should happen in narrow use cases which will actually bring in benefit, and that becomes the success factor. Of course, when ChatGPT came, it actually is one of the mass deployments, that somebody can, answer your queries without having to, without doing anything, because the machine has been taught so much. The place where I belong to, which is Digital India Bhashini Division, is basically working on one of the use cases, which is the language translation using AI models. And we have actually built up those AI models for translating 22 Indian languages bidirectionally, and also we make computer understand the speech in 22 languages as well as allow it to speak out in 22 languages. So it is covering one of the use cases which can actually be deployed at a mass scale. So the crux of it is that can technology be deployed at a mass scale to benefit the people? If yes, and there is a possibility, it will generate excitement and nothing wrong about it.
Thank you. So we have seen the excitement, but there's also some amount of, at least in a lot of reporting that I see also on television, there seems to be, especially with AI these days, and also to an extent with quantum and quantum computing, there seems to be some amount of magical aura about it, that once these technologies become more mature, much more accessible to everyone, all our problems are getting solved. In another 10 years, AI would probably do, completely magical things, or even quantum computers. So I think, I would ask each one of you to just take a few minutes to tell us what are these technologies, what are the things that these technologies would not be able to do. So in the sense, what is a realistic assessment of what a quantum computer can, what is it actually aimed at? What is it that quantum computer would not do? Or, in space sciences, if you're following Elon Musk, probably, the solution to every problem seems to be, let's go to Mars, right? So what exactly, even in space sciences, what is the realistic possibility of exoplanetary life, settlement, colonizing other planets? What are the things that are feasible in the next, say, 5 years, 10 years time frame, and what are the things that probably is all hype and not true at all?
Is quantum starting?
Yes.
So one thing I noticed is that because I work in quantum, I actually stuck to a time frame. Space went a little over time. So so I will again try to stick to the time frame of the quantum of time, which is 3 to 4 minutes. So first of all, can I correct you? Because your entire question had the problem, right? What can a quantum computer? Quantum is not just about computing. And so this is one of the biggest problems we find in reporting on quantum that happens, that, something we do in quantum communication, something we do in sensing, some material, the report, the headline says something about a quantum computer, and that whole thing has nothing to do with that computer. So just to, dispel this myth that quantum is much more than computing. And your entire question was about quantum computing. I hope it was not just about quantum computing.
No, not at all.
Yeah.
So the idea was that usually what gets in
That's
in
the
reports
problem.
is quantum computing, and also the way that it's supposed to be a super computer sort of a thing, wherein it's a fundamentally different thing.
It's a fundamentally different thing. Now you are getting there. Yes, good. So I mean, so it is a fundamentally different thing, but it's not a thing. I mean, so the point is, quantum computer is not a device which we can just replace that laptop with, right? And so this hype that we have in quantum is a little bit around the computing aspect. Okay, and so every news report that we tend to have tends to cater itself towards a computing story. And so that makes it a problem, really, because there are many interesting things happening which are not towards this computing. So what is it that it can do? First of all, there is nothing which exists which is a quantum computer. So we have what are called quantum processors, which are made of objects called qubits or quantum bits. And so a certain number of quantum bits are together in this processor. It could be 5, it could be 10, it could be 100. These numbers keep getting talked about. And so these together can do some kind of an operation, which is a quantum operation, using quantum gates. Okay. So then, of course, one thing we have to understand is that there are only 3 or 4 quantum algorithms which currently exist, which really are able to use these gates to the advantage that we want to see. One of them, unfortunately, is the Shor's algorithm, which is the one which we fear, because with a certain number of qubits getting together and Shor running on them, the algorithm, we will have a problem with the RSA-based cryptography. So this is then similarly, so that's based on the factorization problem and its antidote. Likewise, we have the Grover search algorithm. So there are certain algorithms. So these algorithms are proven, of course, and we have been able to run them using the small number of qubits that exist. And we have been able to show that they run. But then, of course, we need to understand that they are not yet at that level. The number of qubits that we have in these so-called computers are not yet at the level that we are able to really see something happen which we can't do using the classical counterpart. And so this quantum advantage keeps getting talked about, the quantum leap keeps getting talked about. But then one has to understand that, this is something which is about what would happen if this number goes up in future. And so at the moment, IBM is making a lot of news. We want the 1,000 qubit quantum computer is coming up and so on and so forth. So that will be able to do, obviously it will run some algorithm faster, because then as you increase the number of qubits, this algorithm is going to run faster. And the whole ball game is to use that speed to our advantage. At the moment, we don't have any algorithm other than the boson sampling problem, which was shown by the Xanadu and by the Chinese quantum computer and all these things, where we have seen that something has been done faster than the best classical computer. So this is the thing that, in a computing scenario, we are in a stage where we have certain things working, but we really need to wait a little longer for this enormous number of qubits to come together to become a real threat to what we are perceiving. But of course, that doesn't mean that the threat is not real, because you see, the progress is proportional to the hype. which is a good thing. So maybe not necessarily, I'm talking globally. I'm not saying in India the progress is proportional. In India, the hype is more than the progress. Yeah. Again, I don't know what gets quoted here. I'm really concerned. So whatever you say, then say it in a good way, so that I get the funding for the next 20, 25 years. Okay. But then it is true that, a lot of resources are being pumped into this. And so there is output happening more at an industrial level, but then also at the individual lab level, the components that are getting built are getting fed into industry. So I would say at the moment, these machines that we have, these noisy machines in the computing domain, they are able to run algorithms where we are able to see what would happen when we have the error-corrected versions in future. So we are able to see the future in some sense, right? So this is a good thing. Likewise, we are able to simulate new materials, which would be beneficial, of course, for various diseases and so on. And then we have these interesting applications where we're simulating new materials, which when they get built can absorb carbon from the atmosphere. So these are all real simulations. So simulations are real. And these things are probably the more ground problems that we are currently tackling. But then quantum is not just about computing. And so I have to talk a little bit about the other two aspects, because this is a problem, So and as scientists, just a small personal anecdote. When I first started at RRI, a very nice work we did was published in a journal called Physical Review Letters, which maybe is something we always aspire to, get published in. And so then a certain reporter from a certain newspaper called me because I was the corresponding author. There was no media cell at RRI. And so then I told them how we did and all, and a nice story came out. And then we had this backlash that, scientists don't talk about where did you come from? You're just 2 years old here in India, and, you're talking about your science, and this is frivolous, science. We are Raman Research Institute. Our middle name is research. We don't talk about our research. You go and find out. So I was really worried, I got it's tremendous backlash I had. So it's a huge change we find now in the whole scenario. And this fear, however, still remains that, if we talk about our science to people, is that going to be seen as, us trivializing what we do? Are we not serious people? That just publish and then shut up about it, right? Like, people will find out anyway, but I don't believe in that. But quantum, there is a problem with that, because now it seems to be such that we somewhere we have to always make it seem like we are working towards that computer. And then, so maybe we will come to this point later. I don't know if you're going to come to this point about how we can improve what we do. Yes. Hopefully we'll do that. Yes. But then in terms of what is possible, computing, hopefully in five years, or maybe realistically 10 years, we will have that machine, whether it's a superconducting one, photonic one, these are all contenders, ion trap atoms, where we will be able to actually run algorithms which will show that quantum advantage. That is bound to happen. But the error correction is a worry. These may not be error corrected fault tolerant qubits, so we will have to wait and watch for that. But communication and sensing are a bit more real as of now, because we do have these devices which are and then there are many companies which have beautiful websites and boxes with nothing inside the boxes as well. And so a lot of nice stuff going on there, but also companies with boxes which have things in it, which are being deployed for securing our networks and so on. But we have to be careful, because it's not unconditionally secure. It's information theoretically secured. So we always have to be on the watch out to see if there is some break that we are missing. So this is something we need to be worried about. We need to do quantum hacking. Very importantly, we need to do ethical hacking to ensure that we are not saying something, we are missing something there. Right. In the sensors, yes, we do have realistic things which are available in small and large sizes, which are able to increase the sensitivity of magnetic fields, electric fields, and so on. So these are things which are real now and will become more precise in the years to come. What will not happen is that my laptop or your laptop won't get replaced by a quantum computer. That is the answer to your question, that this is definitely not going to happen. And not all sensing will be replaced by quantum sensing. Communication-wise also, we will keep talking like this. We're not going to use a QKD device to suddenly talk to each other. So we will reserve it for specific strategic purposes, because they are not cheap. Right. And we hope if the market grows, the demand will increase and the price will drop, but that's not a near future thing from what I can see.
Thank you. Dr. Bhardwaj, what's likely to happen in space sciences in the next 5-10 years? What's not going to happen?
Okay, so I hope many of you may be aware about Government of India unleashing on space ecosystem within the country and trying to build up the space sector in a different way with the opening of the InSpace, NSIL, and many, many startups. If you look into the actual development in terms of what we plan to do in the future, in addition to the application sector, the strategic sector, the communication sectors, and the meteorological sectors, India is planning to go to the moon again with the Chandrayaan 4 mission, which will be a sample return mission. So far, we have just landed onto the moon. Now the plan is to bring back the sample from the moon. This is going to be a very, very complex mission because there will be docking, which is going to happen in the orbit around the moon, around the Earth. And we can undertake this kind of missions with not just one launch vehicle. We have to take 2 launch vehicles to do that. Of course, this is a very near future. So within 5 years or so, the idea is to have a sample return missions, because this is an important aspect if India has to stake on the moon. I know some of you may be aware about Antarctica issues, so I'm just quoting from that as a reference. If you don't have capability to go to the moon and stay on the moon, then probably you may lose stake on the moon. Second aspect is about not just going to the moon, but can astronauts land on the moon from India? And that is the roadmap which is given by Government of India to the country and of course to Department of Space and ISRO, that Indians should land to the moon by around 2040. And there are series of missions which is going to go there. One of them, which is a stepping stone for India, would be Bharatiya Antariksh Station. That means Indian Space Station. And this is also a near term, 5 to 10 years down the line, because if you are taking this kind of programs, you need intermediate steps also. Now, you may be thinking that why we are undertaking this kind of programs, as I was quoting in the beginning that can India go to the moon? And the answer was, can India afford not to go to the moon? So there are many aspects of it. It is science is one of them, which drives all the things. Technology is there as a backing, but it is also strategic in nature. There are many spin-offs, offshoots of such kind of programs, which is used for the benefit of the humanity. You must be aware that in the space we use materials which is very light, but very strong. And they are the one which are being used for artificial limbs now. Your pace heart valves, they have been used as an offshoot of material developed for space actually. So there are many such spin-off which come out from developing this kind of technologies. So this is in terms of the short and long-term program. But you also are asking about some extraterrestrial, something like that.
I mean,
but which I will just reserve it right now because I think we have to complete one round of.
Sure, yeah.
Yeah, the question of technology getting overhyped, and whether it is a possibility or not. And we have seen many such cycles. In around 2000, we saw that internet boomed and then it crashed. But then internet came back very strongly to actually benefit the people in masses and in general. So these technologies will have their hype cycle, which, is predicted by many analysts as such. As far as AI is concerned, government in India is focused upon, reducing the gap between have and have-nots. And AI would be deployed for reducing this gap between have and have-nots. In society today, we have 4 types of divides which was there. First is financial divide, which actually in somewhat way, we have actually covered that divide because we have Jandan accounts, we had Jam Trinity, we had used the internet to fullest extent to make this country financially inclusive. We today transfer money directly to the farmer's bank account at the last mile with just a press of button. So We used that internet which was there, used for advertisement and information dissemination to the benefit of the last mile, by making the society inclusive. We still struggle with three more divide. One divide is about literacy divide. We still have certain section of people who do not know how to read and write, and they only speak. The second divide is about digital divide. We still have people who are not digitally savvy, and they are looking at how do we become digitally savvy, and whether they would be able to use and look at the services which are increasingly becoming digital. And they have to be digital because to serve such a large population physically, it's impossible, both from a perspective of care delivery, governance, even education, and other healthcare services. And the third part of the thing, which our country still has a language divide. We speak about 22 language. Our constitution has 22 languages as scheduled languages, and we speak about 100 languages, which is, spoken by 100,000 plus people. And in totality, we would have dialects plus languages about 1,000 plus. We will be using AI for this, and we will be using AI to actually cater to this particular dimension. We are very focused on what a persona is. That means who is the persona on the other side of the divide which we have, and how that persona can come into the thing by specific use cases. So one of the use cases which is going to be used perfectly is use AI for voice communication, because that's going to transcend all the divides. If a person is not able to read and write, he can use voice to communicate. If we are enabling the machine to understand what he is speaking, and machine can communicate back to him that this is what action I have taken, or he can ask the machine to do this, we are going to transcend the digital as well as literacy divide. And of course, if we are able to translate one language to other using AI, then we are also covering language divide. So increasingly, when we are looking at AI for this deployment, this is what is going to happen as one part of the activity. And the offshoot of that is that we are basically going to look at all the service deliveries, like, for example, care delivery or healthcare. Again, AI would be used for specific activities which are there in terms of disease diagnosis, or, providing consultation, which can be then used by the doctor to increase his productivity. AI will help people to do the job better than what they are doing now, rather than replacing them, which is the popular myth. So, the popular myth is that AI would start replacing people at the end of the day. That's not going to happen. Government has approximately allocated $1.2 billion for that, which includes 7 pillars of AI, which is, having the GPUs which are required. We are looking at approximately 10,000 to 25,000 GPUs. We are looking at large language models which are going to be built in. We are looking at skilling people. Again, the popular challenge which we have today is that the people will lose their jobs. So we are looking at skilling people, unlearning and learning. And then we have applications, then we have safe and trusted AI, and then we have building startups with this. So a lot of things which are being done. So there's going to be time frame in which we will achieve all of that which we are talking about right now. So, but that there's nothing that we will not be able to achieve, is what I would say. And it is a time frame of 6 to 7 years when we will see most of the things which we are talking now happen actually.
Right, thank you. So I've been informed there isn't much time left, so we'll quickly go to the audience Q&A. A mic will come.
Before audience, Amitabh,
Yes.
Can I raise a point
sure.
here? I think none of them actually said what won't happen.
What? Yeah.
So I did the politically incorrect thing.
No, you did.
So I have to be given 1 minute at some point to say how good India is doing in quantum. I mean, otherwise people will slay me.
Actually, my question was something different, but
we are doing a lot in quantum. So jab bhi milega time, 1 minute.
Yeah. I just hope that somebody within the audience would ask you. If they don't, I'll come back to you, because I had something else which we had discussed earlier. But in the interest of time, we'll just collect 3 questions.
I'm Apurva Puranik. I'm an art person here. I'm a medical doctor, a practicing neurologist. And as our moderator started with the word hype and hyperbole, my comments are, number 1, whenever we report as a science, well, I'm not a journalist, I'm just a science communicator. But whenever we talk about these achievements of our country, we should pay attention to what other countries have achieved, and so that we are not going into hype. We have reached the South Pole, but what China has done, or what other countries have done, or what US has been doing in all the fields, we should put a comparative reporting. That's one. And the second hype is particularly in the field of quantum. This is one of the most misused words by the pseudo-scientific discourse.
Yes.
And for example, the mumbo jumbo of Deepak Chopra type. So we must have to counter that also as a part of our science communication.
Yeah, thank you. Anyone else, please? There are. Let's just collect the questions quickly, please.
Hi, I'm Payal Thar. I'm a freelance journalist. I have a question for Professor Bhardwaj. How come it has been over 50 years and humans haven't landed on the moon? I mean, I know this question keeps getting asked, but I have never actually been able to get a satisfactory answer.
Yes.
I'm Ankush and I work for Business Insider. I had a question for Amitabh sir. It seems like the world has taken hit the ground running with respect to AI, and everyone, it's almost like a rat race. You have to get into it or you sort of fall behind. But there's still so much research on how water guzzling it is. So where do you find a balance between do we spend more on AI to help connect communities, or how do we or do we use the water to address our water security?
Right. We got your question.
Hi, I'm Shuli Mitra. I'm a science communicator. My question is, about the topic over here. So, small stories. You're representing some of the biggest organizations in the country. How do you think institutions can ensure that more small stories are told by media people getting more access to scientists who are working in, say, smaller labs in the country? Thank you.
Yeah, thank you. So let's begin with the 50 years of moon landing. Why haven't we been on moon again?
Okay, so
That's
I think the question is that
yes,
moon has landed. Man has landed on the moon in 1969 itself, and then why we are talking about going back to the moon. So if you look at the moon itself, there's many things which is unexplored, and one simple example is the discovery of water. Humans landed on the moon in 1969 and continued to do that for next 4 or 5 years up to 1973. But water discovery happened in 2008 by the Chandrayaan-1 mission. Is it not possible to have the discovery when the humans have landed? Similarly, when you talk about many other things about the moon, there are many things which is still unexplored. We are not talking about landing on the moon in the South Pole. Nobody has landed around the South Pole. It is difficult because moon is almost vertical. As you go towards the pole region, the amount of sunlight which is reaching is less. And you need solar panels to generate power. There are also technological issues which happens when you go towards the polar regions. Okay. But coming to the question of why we should start again exploring the moon. It is our nearest celestial body, to safeguard the humanity, if you talk about humanity, and to develop technologies which will enable us to do more exploration. You have to do experiments only on the nearest body. And nearest body is the moon. You can think about moon, Mars and beyond, but then again the question comes is communication and time travel requirements. And therefore, we have to keep working on developing things which will enable us to use moon as a base for future exploration. The point is not humans going to the moon, but using moon as a base.
Thank you. Amitabh, about the water, sort of extra use of water in AI systems, mainly I think related to...
I will answer it in one, means I'll try to give some similarities, but see, the point is that if you are using or doing something which is, away from the natural things, you would be hurting some part of the thing. It's a question of creating a balance, right? So, if you are a lover of cricket, it does not mean earlier we used to play spin well, bowl spin well, and do very well in the country. Now it's reverse.
Right.
We need to strike the balance, right? So we need to continue to do new things, but need to strike the balance where it goes across. Yes, We should not overdoing creating data centers which will actually churn the AI models and try to bring out answers to the question which are there. But definitely we should do enough so that we don't hurt the environment, but still are able to balance this thing out.
Or maybe locate the data centers closer to where
Closer
water is
to wherever
plenty,
it is. So
the
it's a
seashore and
question
all.
of striking
Yes.
the balance.
Yes.
It's not about do one thing and not do other
everything.
thing. That's
Right.
the point.
Urvashi, would you like to take the third question, which was about how to reach out to people who are working in smaller laboratories, smaller research facilities? The scientists working there often don't get to the media. So, what I mean, how do you deal with that kind of question?
How do I deal with that kind of? This was the. I didn't expect this question. So how do you reach out? I mean, this is a difficult thing. I mean, by email.
So it's.
I mean, so what you want to probably ask is that, there is a lot of interesting things happening in, let's not use the word smaller labs, but maybe in labs which are not necessarily, getting reported on because of lack of whatever, right? I mean, so that is probably where we are. And so I think this is directly, I mean, I raised this point earlier as well, that, it's not about small, big, medium. It's about also the mindset of the scientist who's actually working in this scientific discovery or space, whether he or she actually wants to even have that work talked about beyond the scientific publication that they may have engaged in. And so there is a little bit of an issue, because I do believe that there is a fear that doing that is going to sort of trivialize the science that they are doing. So I think the problem is not just with the science journalists not being able to do a good job of, reporting on some of the other things which are happening, which are not getting reported on. It's also the other way around. I don't think the scientists themselves are very proactive per se. And we had this discussion when Shubhra was there in one of the conferences we had organized, that this is a common taboo in some of the some elite so-called elite institutions as well, that if this gets talked about, that means that this is all incorrect anyway. But that's not true. So where we need to actually do a better job in is ensuring that what we are writing as science journalists is not untrue. Sometimes that tends to happen, and that probably is the reason why scientists fear, even sort of venturing out to talk, because if there is a beautiful formula that is discovered, the person may say, but this is not going to really appeal to the newspapers, and then they don't even worry about it. So maybe a little bit more encouragement from our friends here would be nice, that nothing is small or big. It is about the discovery. And it need not always be a discovery related to something which is currently much in the news anyway. And there's one more thing. I think space is wonderful. And of course, Anil, I know for a while, right? But then I think ISRO's things get a bit over-reported. Exactly. With due respect. I mean, so there is a huge article, half a page, on what it wants to do. It's nice, but then maybe we should have at least 1/10 of a page on what even quantum people want to do is also a nice thing. It's not always about having done,
Thank you to all our panelists. Thank you. We're really running short of time, but maybe in fact, I had a few questions which we'll take up later. Thank you so much for your patience and coming here. Thanks.